All right, guys, it looks like we are about ready to kick this off. I am going to be a little bit distracted, sorry about that everyone, because I have multiple screens that I'm trying to pay attention to. So you guys, if I look like I'm lost and trying to figure out which mouse I'm grabbing and stuff, it's because I got multiple computers here, and I've got some people on Zoom, and I'm going to have some people watching on YouTube, and I'm trying to coordinate all of it all at once. Okay, let's see. Let's mute that so you guys don't get a crazy buzz. Okay, so if you're on the Zoom and you have questions, just go ahead and ask them openly. That's absolutely fine. I have no flow whatsoever, so some people are worried that they're going to interrupt my flow. It doesn't happen. I have no flow whatsoever. Okay, so if you have questions about what I'm talking about, or if you can't see something clear enough, let me know. I'm going to zoom in and get you nice and close so we can talk about ESUs, the different types of ESUs, and the equipment that we use to test them. So if you guys are ready, I think I have everything finally done. Absolute chaos, folks. Trying to create social media posts, trying to set all this up and everything. And if this goes off without a hitch, then this is a success, all right? If you guys are watching on YouTube, go ahead and write your questions in the chat over on the side, and I will go ahead and answer those questions as they pop up, all right? So today we're going to cover theory. We're going to cover different types of ESUs because there are some pretty big differences, and ESU technology has migrated to newer tech, which is over there on the side. We're going to cover that as well. Some people are always questioning us, like, why would we need some of the latest and greatest ESU analyzers? And that is because some of them are much more capable than others, and we're going to go over that, okay? So today is going to be an operational overview of ESUs and the analyzers. We're going to go through the menus. BC Group, I've used their analyzers for probably over a decade. It's been a while. I've been doing operating rooms for like 21 years. So I've used their ESU analyzers for many years, and it's very interesting watching the evolution of the tech. And we're going to go into some of that here. It's going to be great, guys. Okay, so can you guys can all hear me pretty good over there? Yeah, I take it. Hopefully so. I'm using a non-standard microphone, so if I speak a little bit loud or anything, it's because I'm pretty excitable, and it just is what it is, right? Okay, so let's go ahead and let's introduce you to our first contestants. And here we go. All right, guys. So this is what we're looking at over here. I have the ESU-2350 Electrosurgical Analyzer, and I have the ESU-2400H. That's the H model, which does actually stand for high frequency. That is because some of the newer units, this guy and this guy over here, they are high frequency electrosurgical units. And that means that they are hitting up in the megahertz realm, which is, it gives a lot of problems to older electrosurgical analyzers, okay? So this unit right here is specifically designed to handle those high frequency bursts, and at the same time, we're gonna go over a lot of the processes that are being automated inside the 2400 that you might have to do manually on the 2350 over here. And that's not taking anything away from the 2350. It's actually designed to be very transportable, lightweight, and easy to use, and we're going to cover that, okay? So anyway, I have some other accessories here with me. I've got a tissue response load box. I have never used one of those before in my entire career, so today maybe you and I are going to figure it out, because it is what you use over here for ligature, and it simulates human tissue, and it does so because the resistance is supposed to increase as its usage goes on, as you activate it, and then it will cut it off automatically. That's the beauty behind ligature, and it's normally very difficult to figure out what that value is. This guy right here is designed automatically to handle that function. I've got Olympus ESG 400. I have down here the infamous Valley Lab FT10. I've got a ConMed Hyficator 2000. And over here, I've got a Curus. That's a Sutter Curus. And believe it or not, I've never seen one of those in my entire career. And I was playing around with it yesterday, and I had some very interesting results because it's kind of a semi-intelligent ESU. Not that these ones aren't, but that one there, it's got some little quirks to its programming. So anyway, guys, most of you probably have this Covidian FT10. Olympus has gained a lot of market share, so you're going to be using a lot of that as well. The good thing is regardless of what manufacturer you go with, they've somehow standardized on what type of ports we have, which means that monopolar and the bipolar are going to be semi-universal. So if you are the old school method, which means you are using a pen, most pens will work, but they're not a safe way of testing ESUs, okay? We are dealing with many, many volts, so we are trying to do things as safely as possible. For testing the monopolar over here, we have this adapter, which we do actually sell in our store, and it allows you to connect a banana plug safely to the ESU analyzer, and it's a contained environment. These silicone high quality cables can handle the high voltage and high tension. The Olympus is kind of a special child. It has a bunch of extra features and whatnot. We're not going to be actually doing PMs, guys. We're doing a operational overview of the technology. I'm going to show you guys how to take measurements, and then we're going to go into the menus because a lot of people are confused about what a lot of these plugs are for on the front. And there is, God, I hate those ESUs. There is a functional reason for all these different types of plugs. We're going to go over them, okay? I cannot tell you about the universal plug on the front of this guy here. What? Okay, hold on. Who has that? Hold on, guys. Uno momento.
No, you're good, Justin. We log in on the meeting invite that
Okay.
you sent to Jason.
Yeah.
And he's still waiting for you to join.
Is it really?
So I did my phone and you came on my phone.
Well, thank you for notifying me on that. That's one of the quirks to Zoom, is that it can create multiple meetings even though it shouldn't. So that is not good. Well, everybody else is using this link, so you found me. Thank you for that. So down here, I'm going to post in the chat the current invite, which is, copy invite link. And if you guys want to send this to anybody else, over here in the chat on the side is going to be the invite link. You can copy that and send it to anybody else that wants to join. I am also streaming on YouTube. I apologize. That was Zoom. Unfortunately, like I said, it's got some quirks. So anyway, Belinda, nice of you to join us. Okay, guys. Let's see. Zoom. And let's spotlight for everybody. There we go. Okay. Can you guys see it better? Okay, guys. So all these guys have semi-universal ports. There's some special things. Luckily, the return electrode is going to be a kind of common port. So a lot of people use banana plugs. You're going to find that they're going to work on everything. Okay. So let's first talk about what monopolar is, because you have to understand what these types of functions are in order for you to select the correct menus over here on the ESU analyzers. So monopolar, it's going to send out energy on one of these ports, and it's looking to return that energy right here on this probe. And this is sometimes called a dispersive electrode. It's called a bunch of things for different manufacturers. This is honestly, when we are testing ESUs, this is the most important thing that we test on the entire ESU. And what it does is this guy right here it measures resistance between these two pins, and if that resistance increases, then all of these ESUs will automatically adapt their output according to the new conditions that it's measuring. There is a little dingle hopper, that is official term by the way, that sticks out right here that will signify that this guy is either a split electrode, so it measures resistance between the two, or a single electrode. And you see a little indicator right here on the front of these ESUs, and that is going to signify what mode you're currently in. Now, I have it chopped off on this guy because as part of your testing kit, you're going to have one that is joined, and we have one that is separate, okay? So this one right here is separate. You can see right here there's two banana plugs. This guy right here has a single banana plug. They serve two complete different functions. The reason that we have this one here into a single is because you want all that energy into a single point so that there's no, what would be the correct word? Anyway, we're not going to attenuate the signal going through any resistors or anything. You want it direct as possible. So let's go ahead and connect that guy back up there. It is definitely not happy, and that is because we have to put this guy in demo mode. Okay. That should stop those alarms for the time being. Okay, so CQM, REM, depending on what year of ESU that you're working on, it's all technically the same thing. And what it is it's technology of measuring resistance and making sure that your unit is identifying that your pad is peeling off, and also that as the resistance changes, it's changing its output. So a normal output for an ESU will look like a curve. So it starts out low, and as the resistance meets the sweet spot, it'll be at the peak, and then there's a falling off point. The resistance gets too high, and as it's getting too high, it's kind of representing the pad peeling off of the patient, and it attenuates, and it just kills the amount of output for the generator. And the cool thing is we can map that out on the ESU analyzer so you can see that curve, which I highly encourage people to do, especially if you have ESUs that are maybe acting a little finicky. It's a performance test. You hook up this electrode right here to your ports, and you run a test where it maps out the curve, and it's so cool. We will probably actually run that one in just a moment. So anyway, this electrode right here is only required for monopolar. For bipolar, standard on most units, we use these banana plugs that have the sleeve that protects you, okay? There are different ones. Some of them have non-retracting sleeves, like this guy right here. It doesn't work, okay? The other important thing to notice for bipolar is almost all bipolars have some sort of micro switches that signify when something's connected. So when you push it in, it has to hit that little micro switch. Other words, it thinks nothing's connected, and it won't output or activate bipolar, okay? So we're in demo mode right now, which allows us to do a lot of cool stuff. I have just a couple different cables, and I'm going to be doing most of my demonstration over here on the ESU-2400. I am going to zoom you guys in. So a lot of this is going to get a little bit darker because you can tell the screens on these guys are very bright, and since they're very bright, it's just not liking it for a camera. It's so difficult to camera for a pickup to the screens. This guy over here is picking up just fine, but this guy right here, not so much, all right? So let's go ahead and zoom you guys in. Boop. Sorry guys, my camera has a mind of its own. All right, let's zoom in a little bit more. And like I said, it's gonna get darker, guys, because I'm going to adjust the image that allows us to see these screens. Okay, let's turn it up just a little bit. Okay, now you guys can see the screens on the ESU analyzers. I know it's dark, I'm apologizing guys, but it is what it is at the moment. Okay, so on the main screens we have auto sequences. So that means you click this guy here, and we have sequences built in for most of these already on this. All you gotta do is go into the menu, find the auto sequence that you want, and you select it. Like this guy here is an FT10. We can load the FT10 menu. Okay. And it's going to load the sequence, which is going to walk you step by step through a PM. It's kind of cool. I wish we would have had that 20 years ago when I was struggling as an entry-level biomed. And then all we do, you can look at the different steps of the test. There's obviously a lot. We're not going to go through them. Folks, we would be here for the next hour and a half. And then you click Start Test. And unfortunately, I got to dim it down a little bit more. This is a bright screen. Okay, so here on this screen, you enter in your generator information, because what we're doing is we're actually creating a legal record. So you can type in its asset ID or whatever, and then down here at the bottom, kind of a cool feature, you can add a signature to the work order. Pretty crazy. Then you hit Next, and it's going to give you some disclaimers, to which then you just press Pass. Pass. Of course, you're doing the steps, guys, right? I'm not just telling you to click Pass. There's a lot of stuff to this. It wants you to check the port, check the physical overall condition, and some precautions about the cabling and stuff. It says turn off the power, disconnect the cord from the receptacle, and it wants you to check the foot control and stuff like that. Verify the power cord's good. Guys, the first step to any PM is you should be doing your electrical safety first, okay? If there's problems with the power cord, you wouldn't even be at this step. You wouldn't even be doing your PM. So, and let's see, interlink cable for the interlink. Check the monopolar 1, monopolar 2. They want you to check for physical obstructions in here, which I have seen a bunch of gum and gooey stuff in there. Check for patient return, this guy right over here. Sometimes these pins will get bent or damaged. Check bipolar instrument receptacle, that's this guy over here. These little micro switches that I was telling you about, the little buttons, you want to make sure that they freely move, because if they get gum up in there, they will not move or they'll be stuck down, and that is a fail condition. Ligature over here. Ligature is a port that we didn't really talk about too much. Ligature is vein sealing. That's technically, it's a brand name for what is vein sealing. And it's a bipolar technology, okay? So bipolar is when it sends energy from one electrode to the next, and is used for desiccation of tissue, for removal, or to kill anything between the 2 points. That is what you would normally use bipolar for. And monopolar is when you have an electrode underneath the patient. It shoots electricity through the patient from one point to the next, and you need this. Bipolar, it's normally an instrument. Both sides of the instrument plug in right here. It's like tweezers, and they'll do techniques like dragging the tweezer past whatever tissue they want to damage, and the electricity jumps from point to point, and anything in between gets damaged, cauterized, etc. Monopolar, we didn't cover the different energy types of monopolar. There are a bunch of them nowadays. It used to be, like over here, you can see that we have cut and coag. That's coagulation. So cut obviously means you're going to cut tissue. Coagulation means that you are cauterizing, so you want to minimize blood loss. Bipolar is when you want to remove tissue and stuff, and ligature is when you want to seal veins. Again, blood loss. It's an automatic technology, which is why we have this guy up here, is because we want to automatically detect when that vein is sealed and stop, because we don't want to burn the tissue. We just want to seal it. And as you guys know, tissues are full of like water and electrolytes. And as you seal it, that water is being evaporated, and those electrolytes and stuff are emitted from using steam. And in doing so, your tissue is going to increase resistance as all those liquids just evaporate. And as that happens, the ligature says, "Boop, you're done," and you remove it and you press on to your next thing. So ligature is kind of a cool tech. It's called various things with different ESUs. So anyway, let's go to the next. There are a lot of steps to these, by the way. You're checking the audio. And now we are on monopolar, and it tells you to set it to a certain level. We're using this guy right here. I'm not going to go into that, guys, okay? We will do some energy discharges, and I'll show you how to measure it over here. But we're not going to go through the PM proper, all right? Yes. Okay. On the menus, both these guys have the exact same menus for the most part. There's just a couple of the details because there's extra features. But for the most part, it's the same thing. We have auto sequences that we talked about. We have measure RF energy. That is going to be the standard energy output for monopolar or bipolar or ligature. You can do that through this tab right here. You can see the menu's the exact same. We have power load curves. This is a cool one that not a lot of people know about. And this is where I think if you're diagnosing ESUs, this is where I would probably start. You can configure a load curve. And let's see if I can get the camera right down here on one of these ESUs so that you can see it nice and close. Okay, here we go. So I'm setting up my test, and a lot of your ESUs will tell you the normal range for their load curve. In fact, the old ones like the Force 2 and the Force FX, Force FXC, etc., including the Bovie brands, a lot of the old manuals had an actual chart that showed the curve that you're supposed to experience. So I normally start at 50 ohms. Let's say we end at 1200 ohms. Enter. And then we ask, what energy setting should we have it at? Well, on this particular one, I have it selected for 100 watts. You see that? And over here, I'm going to set my my generator to 100 watts. And let's see, meter. I want it to be in watts. You can also set your units of measurement. We're on continuous. And I want to trigger this with the 2400. Guys, this is where it gets so cool. Okay, so I have this cable option right here, which a lot of people don't even know exists. This cable right here connects to the back of your ESU, and it activates the foot switch. Notice I don't have a foot switch here with me. Now, we do have a couple different options for that. We have a hand pendant right here. These connect to the rear ports for cut and coag. And it has cut, coag, and bipolar right here to activate. Very cool. This is always nice to have in your tool cart because sometimes you're going to be on site and the device doesn't have a foot control like a bipolar. It's just missing. It boogered off, right? This is a catch-all. So you still have to test that functionality even though you don't have the foot control. This guy right here, it's BC20-03004. I will leave links to all this in the video description. So don't worry about that, guys. But notice that this does exist. We also have it on our web store, bcgroupstore.com. Check it out, guys. This guy right here, I really wish I had this back in the day because I used to short those pins manually. And not only is it a little bit of a liability, but it's just a pain in the butt, guys. When we're out there in the field, it's all about efficiency. Okay, so this guy right here, I have it completely set up. I have it triggered. This guy right here is my foot switch. It connects to the front. There is a little port right here. Hold on one second. Update PTZ. Okay. All right, guys. So right over here on my analyzer, there is a foot switch output port, okay? And both of them have it. That's where we can connect these various cables. I'm gonna plug this guy in. Why do I still have this in my hand? Plug this guy in right here. It attaches, and it's going to automatically activate the ESU and take the measurements without me. How cool. Okay, so let's go ahead and let's zoom you back in so that you can see what's going on my screen. Now, the ESU over here, I set it for 100 watts, pure cut. We have my yellow electrode connected. Again, sorry guys for it being so dark. It just is what it is. And I have my patient return electrode right here. It is connected to my CQM, or my dispersive, right here on the front of my ESU analyzer. It got darker. Okay. Well, I can tell I'm going to fight this the whole entire way, guys. Okay, let me make it a little bit lighter for you guys, all right? Okay. There we go. Okay. Well, you see how finicky it is. So right here is my CQM ports. There's 2 of them. The reason there's 2 is because when we take our resistance measurement and we set and test those alarms, which we will do in a minute, use both those ports. But for these kind of measurements, when you're just checking for the output, you're only going to have it plugged into 1. Okay? Let's go ahead and put this guy back down so that y'all can see the screen, because this is where the magic happens, guys. And let's go back to Zoom. Okay, so here we are. I have it set up, and I'm going to start the load curve. So it says set generator to 100 watts. We're set. Start test. It's activating the generator, and then it's taking the measurement and it's importing it over to here. And what it's going to do is it's going to build out a curve of the outputs. Let's abort that test. Let's go first. Oh, that was my bad, guys. Y'all seen it, didn't you? Here, let's go back into it. Power load curves, configure load curves, start load curve, start. User error, guys, user error. I'm talking too much. Okay, so it tells you the measurement that it had, and it's going to activate it, and it's going to create a step graph right here. As it's increasing the ohms, the resistance, it's going to create a curve. And it's fascinating to watch because every ESU manufacturer does it differently. So right here you see how it increases, and at 100 it plateaus. So when you see in your service manual it says to set ohms to 300 ohms, or for bipolar it's often like 50 ohms, set it for 50. That's because that is the peak or optimal output. And from there, you're going to see that this guy is just going to take an absolute nosedive. And it's going to do that because it assumes that the pad, the patient return pad, is ripping off the patient. And that is bad juju, guys. Okay? You can see it's doing a little bit of wavering because the resistance is now kind of high at 500 and some ohms. That's kind of high. Now, one of the things I will tell you is these, the FT10s are very, very robust units. So it's going to have 100 watts all the way out to like 1,000. It's going to be pretty high. But notice how it's doing it all automatically. I don't have to activate it. It's beautiful. Having this adapter and having this foot control right here, they are time savers. Anyway, you guys get it. It's going to map out exactly what's going on. And if you have one of these units that is being a little bit of a pain in the butt, one of the good techniques that you can use is get 2 different units and do a power load curve. Do a known good one versus the one you think is defective, and watch the curve, because they should match up identically. And if they don't, that's because you have something seriously wrong with your ESU. So if a doctor says, hey, I think there's something wrong with it, sequester that unit, run a power load curve on it, and actually see, is it really mapping out correctly? Okay, guys, let's see. I'm going to adjust the image again so that y'all can see a little better. Okay, that's actually kind of good right there. Okay, so while we're at it, we might as well just go right into measure RF. It's right there at the top, okay? So let me punch in so that you guys can see the menus. Let's talk about what's going on here, because this is where the different types of ESUs, you're gonna have to set it up differently. I think I can get you guys in nice and close. There we go. Okay, so this is the energy measurement main screen right here. So we have hold. Obviously, that's going to hold your value. It's very similar to like an oscilloscope. We have measure RF. We have tissue test. Tissue test is where this guy comes in, guys. And it actually shows you a picture of this guy. You see it? So you can see we have the device under test. We have where this, it says there's the light bulb. That's this guy. It's what it is it's a load. You have to have a load that will change its resistance, which is what this guy here does, the TRL-2400. So you hook it up like that, then you click this guy right here, and it will measure from the ligature port what's going on. We'll maybe run that in a moment. Okay, so one of my favorite buttons on these ESU analyzers is right over here. There's the test setup button. You can see it up here in the corner. When we go in there, it shows you a fantastic color coordinated image of what you need to do. So first off, we have our yellow electrode right here. That's at the top. It's showing you to connect it to the yellow on the ESU and to your active on your device under test. That would be this guy. Next, it's saying to use your dispersive, and I want you guys to pay attention over here. It shows dispersive 1 and dispersive 2, and it shows them both connected over here at the same point. That means that it's the same cable. This guy right here, the one that is put together, this is the cable that you need, and you only need to connect it to one of your CQM ports, which you can see right over here. See it? We have this guy here, the yellow one there, and I have a green one right here, which we will use in just a minute for leakage, but I connect it anyway just so that these two devices are at the same potential. And this ground, earth ground, is connected to the earth lug, which we normally do electrical safety measurements on the back of the FT10. That's where it's connected. So let's go back over to our menu. I love the test setup because as you're going to see in some of these tests, they can be kind of complex, especially on some other ESU analyzers, but you just follow the colors, connect the cables where they say to connect them, and it is very easy. Let's test setup. We have display parameters. So this means if you're doing a lot of ESUs, you can run 2, 3 different readings all at the same time. And we have the unit of measure. You can see we have watts, we have milliamps. That's the two main ones. But look at all these other things. We can do volts peak, peak to peak. We can do volts peak plus. We can do V load. I mean, usually milliamps. 2 readings. We can run a lot of readings, all readings. Look at all those numbers. If you're doing a calibration, you can see all these numbers all at once, and they're reasonably large numerics. So if you want your numerics to be larger, like here, just run fewer of them. But for the most part, we run 1. And you can see we have it on milliamps. Most ESUs are going to be in watts. Super easy, touchscreen. And let's see, down here we have show graph. Okay, so this guy right here, you are going to use, if you're doing like load curves and stuff, you can save it, you can load it, you can export it. We have a USB over here so that you can include that as part of your equipment record. I don't use it very much, but then again, if you're calibrating devices and stuff, you probably will. Our next button down is averaging. Okay, so when it comes to the speed of the ESUs and the speed of the waveform, for the most part, it doesn't really matter because these ESU analyzers are super fast as it is. So sometimes I have it on medium, sometimes I have on fast acquisition. That's just, if you're taking an average of what the waveform looks like, because the waveforms are very different, it's going to do a fast acquisition, medium acquisition, or it's going to take a minute and it's going to say, okay, that's what it is. And while it says slow, it's in milliseconds. It's so fast you don't even notice it, but still an option. So auto range, Now here on old ESU analyzers, we used to have to set like low or high. It used to be a micro switch. Here you can see that we have auto. I love auto. Like I said, the processors inside these guys are so fast, we don't need to set it for high or low. But if you don't want it to flip-flop around and you just want to see some precision, maybe you're measuring something really low, like my bifurcator up there, then that's what we would do, is we would set it on low. Here is a pretty big one, guys. As ESU technology has changed, it normally would be continuous, but now we have pulsed ESUs. You see that? And notice how it gives you a waveform of what to look for. Now this is where a lot of the older ESU analyzers, they cannot keep up with this. You see how we have a little pictogram of what the different pulses are? Inside your user manual, you should have a depiction of what that waveform looks like. And if you're still curious, we have up here on the oscilloscope output, which I have right here next to my foot control. A lot of people are wondering, what is this guy for? This is actually a very useful tool. This is a BC, it's a BNC. It's a BNC connector, and that would run up to your oscilloscope, and it's an attenuated signal that is going to output something that looks kind of like this. So when you're running, especially a unit that is a little quirky, or the doctor says it doesn't feel like it has the correct output, you would hook up a oscilloscope to this guy and set it right here. I was going to run a couple demos for you, but I'm clearly not going to have time. And you will see the different waveforms. So like cut 1, cut 2, coag. There is a definite difference in the waveform, and that's why you would use the oscilloscope output. I would suggest doing an energy output and take a look over here, match it up to one of your modes if it's a pulsed ESU, and then you select what one is closest to what you're seeing on the oscilloscope. I am not. We are going to do let's just accept the changes. Measure RF energy. Anyway, here we go. I don't want to do a pulsed waveform. I want to do continuous, sorry. So down at the bottom is continuous. Continuous is what most of these ESUs are, but some of them have some trickery, okay? So if you're starting to get random readings and stuff, that's why you want to go into pulsed waveform. Check it out, okay? Down here at the bottom, test load. We are all very familiar with test loads, okay? Normally you're going to run internal, and you can select your test load. I mentioned earlier that your ESU is going to perform differently based on the load that is going to be across the CQM. Well, here is where you can set that, and it's super easy. 300, enter. There you go. My test load is now at 300 ohms, and now I can start doing burns. Down here at the bottom, we have two options. One of them is isolated, and one of them is ground reference, okay? Most ESUs are going to be isolated. It is all newer. Isolated is obviously safer, but what we are saying is that you are not part of the current path. It normally passes through your body, but it's not intending for the electricity to be absorbed by your body. Ground referenced is different. And like the bifurcator up here, there is no return electrode, or I mean there could be, but usually how they're using it is just the pen. And it's not a bipolar instrument, it's monopolar. It's just your body has a certain amount of capacitance, and when they do the cuts to cut moles off skin and stuff, your body is basically taking that charge. You're part of the circuit path. So that's for ground reference, and that would be like the ConMed bifurcator up here. Normally we're going to be on isolated. Now, foot switch. I mentioned earlier that we have this magical little foot switch cable down here. Here's where we can set it for what we want it to do. The guy right here is currently set for cut, but I can set it for coag. So if I'm having the generator automatically doing my foot control for me, this is where you have to go through and change it. So I would first do like all my cuts, then I would go through and do all my coags, and then go back through and do all my bipolars with moving the cables around, you know. So, but this is where you would configure that, is right here. So let's put it back to cut. You also set an activation timeout. You notice when I was doing that power curve earlier, it would energize and then it would take a break. And then it would energize and it would take a break. It takes those breaks because that is called duty cycle. These ESUs, they actually have something called the duty cycle, which is for the amount of time that is on doing a burn, there's a certain period of time it has to be off. Those components are not 100% duty cycle, which means they're on all the time like a light bulb. No, they have to be on for a certain period of time, and then they have to be off. They have to cool, they have to relax, and then you can energize it again. So this right here, the activation timeout, this is where you can set some of that, okay? And down here in the bottom is where we activate the ESU. Pretty cool. And you see, this one here is spot on, of course. We have 100 watts on our ESU. You can see it was registering beautifully over here at 100 watts. So that is for monopolar. Let's go ahead and let's set it up for a bipolar configuration, okay guys? And to do that, let's see, let's update the PTZ. Okay. For the bipolar, we are going to use 2 cables. So now we need this guy right here, this dingle hopper, and we need another one. Okay, so this one here, I'm going to place down here. So bipolar does not use a regular CQM port. I can actually remove that cable completely from the port. This is a monopolar cable, okay? For bipolar, what we're going to do is plug one into the second port over here and make sure you depress the little button that's there. And then this guy here is going to come over to your other CQM, just like that. Now, with bipolar, it's going to be, because normally you just have 2 electrodes near each other, it's not shooting through the human body like monopolar, it's going to be much less. So typical is going to be like 50 ohms, 100 ohms. Always check your service manual to set your resistance for what they're expecting, because otherwise your values are all going to be off. Let's go ahead and set it up. I have this one here currently set for bipolar. Remember that, guys. You have to also configure your foot switch. Okay, and we're still on watts. Let's go ahead and let's now turn it up. Let's do a maximum burn on bipolar. 70 watts. Sounds good to me. And now that we have everything configured, let's do a burn. Is it not depressing? Not depressing. All right, here's where we got to troubleshoot where oh yeah. Make sure that all these are in. Okay guys, I'm definitely doing something wrong here. User error. Is it because I'm in demo mode? Well, here's where I would simply go and I would take my hand control that I mentioned earlier. I bet you I have it plugged into the wrong port in the back or not even connected. So let's go ahead and plug this guy back here just to be sure. And mind you folks, our ESUs here, they might be here for a reason. So that I cannot say for sure that these ones are 100% working. All right, so this is my automated cable that I'm disconnecting. And now, there we are. This is cool because I can now show you guys the hand control and how useful this guy can be. Okay, I think I've got it screwed in plenty enough. Okay, so this works the same as if you have a foot control. And you can see there's my cut, there's my coag. My bipolar port is not working. See, this is where this all comes out pretty handy. Let's see. Standard precise macro. Says additional features. Auto bipolar. No, I definitely don't have auto bipolar set up. Okay, well, so my ESU is defective. In this case, it would be a fail on my PM. However, we can also go up here and we can set up bipolar on this guy. This ESU up here. Again, guys, the banana plugs, they're kind of universal. Let's go up here and let's do take it up. And let's see, do I have the foot control for this guy? All right, check this out. I've never tried this before, but here is an automated cable for the Olympus. So we can disconnect that one. We connect the Olympus automatic cable. Okay. And most of this stuff should be the same. Bipolar. Medium averaging. Continuous. Configure foot switch. Oh, we do have something. Select a mode. Okay, we're going to do bipolar on the foot control. All right. Bipolar cut. All right, guys, I'm clearly doing something wrong. Effect 2, I'm on bipolar cut. I was never good with these Olympus units. Foot switch. Bipolar. No, it won't even allow me to select it. Well, you guys get the gist. Jeez. Okay, I'm running out of time, so I'm going to have to cover as much as possible, and I don't have time to sit here and figure out what I'm doing wrong. Okay, let's go to the more important things that most people are probably going to be unaware of. Let's go into measure RF leakage. So we covered the power load curves. REM CQM is also, like I said earlier, it is probably the most important thing that you're going to do on an ESU, because what you're doing is you're going to be submitting a resistance and you're going to see if you get an error code over here. So let's see, we're in. Let's go ahead and set it up. So on the old school ESUs, when you have a single electrode, it would error if it was above 10 ohms, because obviously you should have very low electrode resistance if it's one electrode. But on the split electrodes, you should be able to go up to, I think it's 135 ohms. Enter. Oh, you see? It already doesn't like it. That's the upper edge of what it's supposed to tolerate. And over here we can change by percent or we can change by ohms. So let's go ahead and change it by 5 ohms. And notice how the alarm went away when I immediately touched it. Unplug this bad boy, plug it back in. And this guy here is not going to be happy until it's below 10 ohms, because my dingle hopper is missing. The little pin that's supposed to sit right here, it contacts a little micro switch in there and it tells you, hey, I'm a split electrode. But you guys get the point. It's super easy. We can go in and we can change it. You can also zero it. Quickly drops it back down. You can make sure that it's detecting. Open circuit. It's giving you an error code. That's fantastic. Let's go ahead and close the circuit. And let's go back to the main menu, because we are going to do RF leakage. This is going to be a very important one. I really want to cover this for you guys. So let's go ahead and let's zoom in. And I'm going to show you guys the difference between these analyzers and why I always recommend to people the 2400. I like the 2350 up here. I really like it. It's actually a revolutionary design inside. It's pretty cool. Very lightweight and it's compact, like it's super lightweight. But this guy down here, it has fewer ports for a reason, guys. Because this guy has little switches and stuff inside that do a lot of the telephone operator stuff automatically. Okay, let's go ahead and get rid of this cable. Okay, and let's go to measure RF leakage. So we covered REM, ARM, CQM. Now we're going to go to measure RF leakage. And here is where a lot of people are just lost. So we have 4 different modes for RF leakage. Like mode 1 is when you have no return electrode, which that's not a return electrode. Mode 1 is when you have no return electrode, and they're saying what would happen if the device is activated or hot and you don't have this electrode. They want to make sure that the doctors and patients are not part of the path. So you have that one, and then you have a leakage where the electrode is there, it's functioning. And then we have leakage 2 and leakage 3. One of them is for in case the case is energized. They want to make sure that if somebody comes over and touches the case, that they're not going to become part of the circuit path. And the third one, I don't even remember. I did remember, but I didn't. So the fact of the matter is these are all regulated by ISO 60601 something. But here's the cool thing. You don't have to remember any of that because all you got to do is you're going to test them all. You just come in here and hit test setup and take a look at that. Now, as I said, this first version is what if we don't have this cable connected? So all it's saying is you have a yellow electrode and a green electrode, which I told you I connected to the back to the lug nut that's on the back of this guy. That's your grounding lug that you normally connect to for electrical safety. This little gator clip's going to connect there. And then what we're going to do is we are going to see how many milliamps we have. And of course I disconnected this guy again. And I can activate this remotely using the foot switch cable. Or if you guys have foot switches connected, why bother? Just use the foot controls that are there, right? Okay, there's one. And come on, Valley Lab. There we go. Okay. So there's my automated cable. And let's configure foot switch for cut, because that's what we're doing here. According to the test, we're doing cut. And medium averaging, test load 200 ohms. Again, that test load is going to be listed in your service manual, so remember that. And then you either depress the foot switch yourself and get a measurement, or I do it here automatically. There we go. All right, now we're ready. Run it. Mind you, this ESU wants to be put in service mode. In other words, it's going to alarm because it's looking for that REM. Demo mode, enable. Okay, now let's run. Okay, in this case, I am getting 46.2 milliamps. This seems like it's kind of high. Anyway, let's go to leakage 1 Bravo. Check on the test setup again. So here, we're going to see what it's like without the active electrode. Instead, we're looking to see if we just have a dispersive electrode connected, which is going to be one of these cables here. This guy. All right. Too many cables, guys. So we connect our dispersive electrode, according to what it says right here, and then we take this guy over here to the blue port, your CQM, and then we hit the foot switch. Okay, in this case we got 66 point something. Next, let's go to leakage number 2. So leakage number 2 is where most people get it all mixed up. If you are using some of the other brands of electrosurgical units, you're going to see like you have to pay a telephone operator in order to make leakage 2 happen. But notice this, it's just asking for yellow, blue, and green. I could not believe that we have made it this easy, guys. There we go. Yellow, blue, and green. And mind you, all the telephone operator stuff inside here is happening all automatically. Okay. So now let's take a look at what this would look like on another ESU analyzer. So let's go to here. I'll show you guys what it looks like so you can do a comparison. And let's zoom out just a little bit so y'all can see it. Okay, so here's 2 different ESU analyzers. Again, all the ports on the front right here. In this guy up here, we have the active electrode, yellow's yellow, right? We have loop, which you see it says a little current sensor right there. That is because there is actually a coil, whereas on the old ESU analyzers, we had a separate coil that you had to pack in your kit and you had to unpack and hook up. We have it on board as part of it. But you can see there is a silk screened depiction of it, so you know exactly what 2 ports are needed for current sensing. Then we have our main load right here, which is 0 to 5,500 ohms, and then our dispersive or CQM, because people call them different things, right? But again, there's a depiction showing that these 2 blue colored ports are related. Over here, I have a 200 ohm load, and there's 2 banana ports right here. That right there indicates, let's say you as a human or as a patient, that 200 ohm load is supposed to depict a human body, what if, which is what we're going to see in just a moment. And then down here, we have 2 earth, whereas this we have only a single earth down here. We're going to show you that you're going to have an extra cable for that earth because one of them is going to connect over here to this guy, but the other one's going to connect over here for current. So let's go ahead and let's take a look at the exact same test. Leakage 2, down here, you can see it required 3 cables. Up here, leakage 2. Let's see exactly what's required for these 2. Okay, so on this one here, I'm supposed to connect 1 cable from this one, which is the active, to that 200 ohm. So I'm depicting a human. What if you went up and touched the device? And then you have output from 200 ohm, supposed to connect to one of the greens right here. And it's so easy to follow, guys. Yes, you have to set up some stuff, but it's super easy. And then the green right here is the same green right here. It connects to the lug on the back of the device. And the bottom, the dispersive, now goes to your yellow. So it's the same exact thing, but you can see why on the 2400H, the 2400 series, it's so much easier because if I go from leakage 2 to leakage 3, I don't even have to move my cables because inside this guy, it does some magic and it leaves the same cable configuration and you think it's doing the exact same test. It is not the same test, okay? So this is leakage 2. You run it. It's kind of crazy. I didn't even have to touch my cables. Okay, and let's go to leakage 3. And again, you guys are going to see a big difference with the test setup for leakage 3. Notice I still have yellow. I still have my dispersive blue. I still have my green connected to ground. Let's take a look at leakage 3 over here. Oh boy. Oh my gosh. Okay, so my yellow is supposed to connect down here. So it's supposed to go from here to here. And then this one right here is supposed to be my blue CQM. So that one's supposed to go back that way. And from the brown, I'm supposed to go down here to ground. So what we're measuring is the current to ground for a person, okay? And this one right here is supposed to be your yellow. Still super easy to follow. So this one would go here. This right here is my CQM. I would plug this guy right here. I have other cables, so you can see how fast and easy this actually can go. It's supposed to go from there to there. Now I got one more cable. Let's do this yellow right here, where we connect from, let's see, this ground is supposed to go here, and then this ground right here is supposed to go all the way up here to my current, so we're measuring how much current's going to ground. There it is. It's some extra steps, but I still was able to set it up in less than 10 seconds. And to be honest, before today, I've never touched a 2350 in my life. I've only had the 2400. So this is my first time ever setting that up. And I was able to do it in seconds because I just followed the depiction on the screen, okay? Very easy to do. HF liquid, high frequency leakage is normally where a lot of people mess up. And that's because on the older analyzers and some other brands, you don't have the depiction of what to connect where. You're probably going to mess it up. If you want the easiest thing, the 2400 down here, it is the Cadillac for a reason, guys. And there we go. So we just go back and, again, activate the foot switch, which is not connected. It's up here. So let's see how fast I can set this guy back up. Again, blue to blue. Yellow, this guy right here, to yellow, and my earth ground to earth ground. Super fast, guys. Super fast. So there you have it. We just ran through the 4 different HF leakages, and I guarantee you a lot of people don't do it correctly. And for the most part, guys, I know I'm completely out of time. I'm going to apologize for that, guys. There's so much to cover here. I just want you guys to, first off, be aware. Here, let's go ahead and zoom out, guys. Right? Image. Auto exposure. Let's do this. Okay. So first thing I want you to be aware is that there is a different technology in ESUs. Some people think that they're all the same. There's many, many ESUs that can't be handled by many, many ESU analyzers because they have new features or they're too high of a frequency. But as long as you set it up correctly and you use the correct test equipment, you'll get a reliable and repeatable result, okay? The 2400H, it's obviously my favorite for a reason because it saves me a lot of time. But if you are on the move and you are going from site to site, the 2350 up here is phenomenal. The pictographs that show you what you have to do with each step. And I saved the absolute best for last, guys. Oh my God, for you guys. Okay. If you guys are users of MyBC Mobile, we have an app that allows us to integrate the 2400 down here. So if you can imagine standardizing your test, which I don't have time to show you, unfortunately, but we can configure a test. So step 1, it'll configure your ohms, and all you got to do is follow the prompts for what cable has to connect to where, and you can include photos and checklists for what you're doing so that your biomeds are operating at the maximum efficiency. So step 1, you scan the barcode on your device, it populates on the app, says, okay, here's the test for that device, and then it says, here's the test equipment you need, including the jigs. Very important to have the correct jigs, especially adapters like this guy right here. And from there, you begin the test. And it says step 1, we're going to probably measure the CQM first. And from there, you're going to follow it step by step. It's going to automatically set your resistance for you. And you're going to automatically enter when you have an alarm condition. So if you hit 135 ohms like we did today, and it goes, alarm, you hit stop, and it will capture that result. 135 ohms, that's a pass condition. Press on to the next. For energy capture, it says, like, set it at 100 watts. You set it at 100 watts, it automatically configures your ESU analyzer for the correct settings for this device. So if you're using these cables, I had to go through and set like bipolar, monopolar, and whatnot, configuring my foot controls. You don't have to do that. The app will do that for you. This is going to revolutionize ESU testing, guys. I'm super excited about it. And look for it probably in Q1 of 2026. That's when we're going to make it widely available to all to you. I think that they are setting out an email for all the people that are currently about to receive our newest catalog. So if you guys didn't know, BC Group has a brand new catalog that they're going to be emailing out in a couple weeks. I kind of, spoiler alert. So guys, you are going to receive one of those catalogs, and at the same time, I want you guys to reach out to me if you're interested in utilizing my BC Connect so that we can increase your efficiency utilizing automation on things like the ESU analyzer. If you think that that's cool, wait till you see automation of things like the defibrillator. Holy cow, talk about a game changer. I can give the app and one of these tablets to a Biomed 1, and we can have them go out there and run the app, and I can have a Biomed 1 doing defib PMs probably better than most of you, because all they got to do, attention to detail, follow the step-by-step prompts, and there's photos that guide them to what buttons they have to press. There's checklists. Guys, software is the way to go for the future. This telephone operator and trying to guess what's going on where no longer is the case. We have pictures that show us what to do. We have apps that guide us step by step, and it automatically captures the energy and it builds out a PDF report that you can attach to your work orders. Or if you are a professional level licensee, it'll automatically take those results, put them into your work order, and it will close the work order for you. That's crazy. I remember back when I was doing ESUs, we would have a paper chart, and we would have to sit there and fill out like monopolar 1, monopolar 2, all the different energy levels, and then bipolar, and then ligature, and then the CQM, all your different results and stuff. And then we'd have to go back and transcribe that into the record, into your CMMS, which was absolute garbage, but we had to do it, right? Because there was no other option. And then came the ability to take a photo. So I would have my handwritten notes, which I have pretty good handwriting, and I would snap a photo of my results and attach those to the work orders. And that increased the speed a little bit. Still very unprofessional. Guys, we can do better. So automation, this guy right here, the 2400, 2400H, if you have one and you might be interested in automating that bad boy, let me know. Justin at BC Group International, INTL.com, or many of you guys know my other email, justin at betterbiomed.com. Write me there. Tell me if you have any questions or whatnot, or if you would like maybe a one-on-one consult with any of the software that I've talked about today, or maybe some of the functionality of your ESU analyzer, go ahead, let me know. I love doing training with you guys. You guys are phenomenal, and I want you guys all to have a Merry Christmas. You guys have been fantastic. So thank you all for watching. Thank you for being part of this. I do not have any questions that have came over. Do you guys have any questions? I would love to answer them. If you do, I know that this is kind of a rushed spot. The other thing I want to maybe showcase is this little bad boy right here. What a cool device. This is a CQM tester. And instead of having a giant decade box with all these 100 flip switches, look at this. I got 3 rotary knobs. So the top one is by 100. So I mentioned earlier 135 ohms. That's 100, 3, 5. Bam. Is it green? Is it red? 136. Now it's red. It's a passing condition. So red at 131. Large dials with pointers indicating where you're currently at. So easy to read. And there's no mistakes of activating other switches that you didn't intend to activate, like some decade boxes out there. This guy, check it out. This is the CQM 2000 tester. Guys, I love this thing. Absolutely love it. Wish I had it back when I was out there pounding out some ESU PMs. Folks, we covered a lot of stuff, I know, and I talk very fast because I don't have very much time. I only have like an hour. We had to cover a lot of stuff. So feel free to write me an email. As I said earlier, I will include some of these links down below so that you can click on them. If you're interested in any of the accessories or cables, it'd be my pleasure to help you out. And if you are looking for a loaner or demo for BC Group medical equipment, go ahead and let me know. I will help you out with establishing some sort of demo so that you can check it out yourself. Some pretty cool stuff, all right? Thanks guys for watching. I appreciate you, and I hope you all have a fantastic day, all right?